Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about polynuclear hydrocarbon. You know, this topic also very important for MSc and BSc third year students. So let us start learning of polynuclear hydrocarbons. You know the topic itself explaining something. Hydrocarbon means carbon and hydrogen. Polynuclear means there are many nuclear. So look at the example, then it is clear to you what is meaning of polynuclear hydrocarbon. Look at anthracene. There are three nuclear of benzene combined in linear fashion. Now look at the phenanthrene. Three nuclear of benzene combined with angular functions. So what is the difference between anthracene structure and phenanthrene structure? In anthracene, ring is attached in linear fashion, and in phenanthrene, ring nucleus is attached with the angular functions. You know, my friends, polynuclear hydrocarbon are hydrocarbon organic compound containing only carbon and hydrogen, and that are composed of multiple aromatic rings. Polynuclear hydrocarbons are uncharged. There is no charge. Non-polar molecules found in coal and tar deposits. Another important point, you should note it down, they are also produced by incomplete combustions of organic matter. Another most important point related to polynuclear hydrocarbon is polynuclear hydrocarbons are lipophilic, and larger polynuclear hydrocarbons are insoluble in water and they are abundant. The most important point which is you should memorize, because you know polynuclear hydrocarbons are considered as possible starting material for a biologic synthesis of materials. So last most important points related to polynuclear hydrocarbon is the class of polynuclear hydrocarbon are further classified as the simplest are the naphthalene having two aromatic ring and the three ring compound anthracene and phenanthrene. Now look at here PNH. What is the meaning of PNH? Polynuclear hydrocarbon. PNH is the short form of polynuclear hydrocarbon. Now there are two classifications of PNH. One is benzenoid, another is non-benzenoid. In benzenoid, we have the isolated and fused ring. What does it mean? Isolated means two nuclear are separated by bonds. So look at here, biphenyl is the example of isolated polynuclear hydrocarbons. Now fused ring, linear and angular. Linear examples, naphthalene, and angular examples, phenanthrene. Now in another side, non-benzenoid example, azulene. So now it is very clear to you what is meaning of PNH, what is the classification of PNH, what is the isolated system, what is the fused ring system. So naphthalene and phenanthrene example of fused ring system, and biphenyl is the example of isolated system, and azulene is the example of non-benzenoid system. And phenanthrene, naphthalene, biphenyl all is benzenoid, and benzenoid and non-benzenoid is the polynuclear hydrocarbons. Now look at here benzenoid, linear combination, angular combination, isolated and non-benzenoid. So now numbering, you can see the naphthalene, you can see the anthracene, you can see the phenanthrene, you can see the diphenylmethane, you can see the trimethylphenylmethane. Now, the structure of naphthalene can be explained on the basis of Kekulé formula, orbital model, and resonance model. Kekulé type formula, the structure of naphthalene is given on the basis of Kekulé formula. You can see the atomic aromatic nature. Very important point and very important topic if you are studying polynuclear hydrocarbons. Determination of elemental analysis and molecular weight shows that naphthalene has the molecular formula. See, you see here it is something written wrong. So, what is the naphthalene? How many carbon in naphthalene? If you go through, then you can see 10 carbon is there. In naphthalene, you can see 6 and 4, 10 carbon. So, C10 and H18. The formula of naphthalene shows its extreme unsaturation state and can also be expected to be very reactive. You know, naphthalene is a very stable compound and undergoes substitution reaction. It does not undergo addition reaction and phenanthrene. On complete hydrogenations under drastic condition, it gives dihydronaphthalenes having the molecular formula C10H18, which is known as decalene. And these properties shows that naphthalene is an aromatic compound with the 5 double bonds. So, what is the molecular formula of naphthalene? And after dehydrogenations, all double bond remove and then become 18. So, you have the hydrogen is 1, 2, 3, 4, 5, 6, 7, 8. So, C10H8. Now, presence of a benzene ring with 2 side chains. Oxidation of naphthalene gives phthalic acid, indicating that naphthalene contains a benzene ring having 2 ortho side chain. Presents 2 fused benzene ring. Eliminator proposed in the structure of naphthalene from the conclusion of Kekulé type formulas ensure the presence of 2 fused ring at other position. Now, existence of 2 monosubstitute derivatives confirm the Kekulé type formula. You know, Kekulé type formula shows symmetry and allow only 2 isomeric monosubstitute derivative to be formed. The hydrogen atom present at mark positively and remain identical. Now, resonance model of naphthalene is very important. You know, the resonance model, according to the resonance model, a structure of naphthalene can be described as following. So, resonance hybrid of 3 forms. Naphthalene is a resonance hybrid of 3 canonical forms. In the re-electron system of naphthalene shows a continuous delocalization on ring system. Now, another most important point for the examinations and for the competitive exams, not all carbon-carbon bond or single bond or double bond length are equal. Bond length of C2-C3 bond is longer than that of C1-C2 bond due to double bond character, and shorter length of C1-C2 as it double bond in the 2 resonance form. So, C2 and C3 bond is single in 2 forms. And so look at here the situations of the resonance. And the 1 to 1.3 and 2, 3, 1.4. There is a difference of 0.4, and that is very important if you are talking about the bond length, because bond length is very sensitive. Now, synthesis. Naphthalene can be prepared by the following methods. From coal tar. Coal tar is the main source of naphthalene. You know, decalene, decahydronaphthalene is the presence of a metallic catalyst at 180 degrees Celsius undergoes dehydrogenation reaction to form naphthalene. You can see that decalene, this is the palladium catalyst, 180 degrees Celsius. It gives this structure naphthalene after dehydrogenation. From Diels reactions, you know, furan and benzene react with to form Diels adduct. However, the reactions of Diels adduct of furan and benzene in the presence of hydrogen and nickel produce naphthalene. So you know the adduct when two compounds combine together forming adduct. And then finally, you will get the naphthalene. Howard synthesis, the Howard synthesis of naphthalene involves, also Friedel-Crafts acylation of benzene. You can see the acylation occurs at one position. And then 4-phenyl butene, the compound 4-phenyl butene when passed over red hot calcium oxide yield naphthalene. Now, from 4-phenyl but3 enoic acid, heating of 4-phenyl but3 enoic acid with sulfuric acid results in the formation of 1-naphthol, which on further distillation with the zinc dust yield naphthalene. So look at here. Now, I am talking about the properties, physical properties. Naphthalene is colorless, crystalline solid, melting point 100 degrees Celsius, boiling point 218 degrees Celsius with a characteristic strong odor. It is soluble in water but is soluble in organic solvent, ether, benzene. It is volatile and sublime on warming. It is also steam volatile. It burns with the sooty flame. So, very important point because it is aromatic nature. That's why when you burn, it gave the sooty flame. Now, I am going to talk on chemical properties of naphthalene. Naphthalene having similar chemical properties as that of benzene, though it is less aromatic than benzene and react more readily. Naphthalene is having 61 kilocalorie per mole resonance energy, and in benzene, which is less than twice of 36 kilocalorie per mole. So, focus on the chemical reactions. So, first is oxidation reaction of naphthalene. When naphthalene undergoes oxidation in the presence of chromic acid, it gives 1,4-naphthaquinone. Also, when it undergoes oxidation in the presence of vanadium phenoxide. Look at the reaction scheme and reactions of naphthalene. There are 4 reactions here. First one, in chromium oxide, acetic acid, you will get the 1,4-naphthaquinone. Ozones, zinc water, it gives phthalaldehyde. In presence of vanadium pentoxide, oxygen, phthalic anhydride, and in presence of KMnO4, you will get the phthalic acid. Now, halogenation. Bromination, chlorination of naphthalene takes place readily and does not require any Lewis acid catalyst in the case of benzene. Halogenation of naphthalene occurs exclusively at position 1. Substitution at position of the naphthalene can be explained on the basis of resonance stabilization of the intermediate carbocation. Carbonations. And when the halogenating agent attack on naphthalene at one position, the intermediate ion form remain more stable apparently. Look at here the reactions. Naphthalene react with chlorine. It gave 1 chloronaphthalene. That is very important point. You should be write it down in notebook. The position. Positions should be defined when you are doing reactions. Now here you can see Friedel-Crafts. Friedel-Crafts methylation of naphthalene lead to the product mixture of beta-methyl derivatives, and Friedel-Crafts ethylation through slightly less yielding offer an beta-ethyl naphthalene. Now you have the naphthalene. You have 2 methods here: methyl iodide, aluminum chloride, ethyl bromide, aluminum chloride. In first case, 1-methyl naphthalene and 2-methyl naphthalene both are formed, and in the next case, second case, it gives the only 2 position 2-methyl naphthalenes. So that is also very important. So Friedel-Crafts alkylation you have seen. Now Friedel-Crafts acylation, you can see there are again 2 conditions: polar solvent and non-polar solvent. In polar solvent, you will get the 2-methyl 2-naphthyl ketone, and in non-polar solvent, methyl 1-naphthyl ketone. And this is very, very important reactions. You should be write it down, you can memorize it, and you can make the understanding Friedel-Crafts isolation of naphthalene depends upon nature of solvent used. If the reaction is carried out in presence of non-polar solvent such as carbon disulfide, then one substituted product is obtained, while in the presence of polar solvent such as nitrobenzene, then two substituted product is obtained. So polar and non-polar solvent, the importance you will analyze here. Now reductions. You can see there are three methods of reductions: formation of 1,4-decalene, tetralene and decalene. So in different conditions, sodium ethanol, sodium isoamyl alcohol and hydrogen platinum and H2 hydrogenation. So naphthalene can be reduced partially to completely to corresponding dihydro, tetrahydro and decahydro derivative under a reaction condition. Now nitrations, you can see the naphthalene undergo nitration, it gives 1 nitronaphthalene, and further nitration at higher temperature, you will get a different products, and that is very important, 1,5 and 1,8 dinitronaphthalene. Now sulfonation, you can see different conditions at 80 degrees Celsius, one substituted product, and at 160 degrees Celsius, you have naphthalene, sulfonic acid at 2 positions. Now, chloromethylations, and that is also very important. Under classical formulating conditions, one chloromethyl naphthalene is obtained from naphthalene. Look at the reaction scheme. So, now uses. What is the use of naphthalene? As a fumigant, naphthalene has been used as a household fumigant in sealed container containing naphthalene, destroy all forms of moths that attack textiles. The other fumigant includes fumigant pesticide that repel insect and protect the contents. So that is very important. Sometimes you will see the naphtha tablets from people's using. Laboratory uses. Molten naphthalene provide an excellent solubilizing medium for poorly soluble aromatic compounds. It is used in the industrial products of phthalic acid anhydride. Wetting agent and surfactant, alkyl naphthalene, sulfonate are used as a non-detergent wetting agents also in agriculture, chemical industries, in textile and fabric industries. You know, my friend, naphthalene sulfonate polymer plasticizer are used to produce concrete and plaster board. Also used dispersant in synthetic and natural rubber as staining agent in leather industries. Used to product dyes, explosive and synthetic resins. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.